Hello students, so I am Indrajit Singh. I am here to teach you chapter number 3, that is gravitation. So in the previous chapter, we discussed about force and Newton's laws. It means you studied about how force can change the momentum and what is the importance of external force by using Newton's first law, second law and third law. So in this chapter, Newton tells us about a force, and the name of force is what? Gravitational force of earth, or we can say that gravity effect. Fine. So according to the Newton, if we drop any stone from the surface of the height, it will attract towards the surface of the earth, or we can say that it will attract towards the center of the earth. Fine. So suppose if we have a mass body here and we have a stone at some height, so it will attract towards the center of the earth with a force. And Newton gives the name that force is what? Gravity, or we can say that gravitational force of earth. According to the Newton gives what? Universal law of great gravitation. And what is that law? According to the universal law of gravitation, every body in universe attract each other with a force. So suppose we have two mass bodies, M1 and M2. Fine. And they are separated by a distance r. So we have two mass bodies, they are separated by distance r. So according to the Newton's gravitational law, that each and every body attracts each other with a force, and that force is directly proportional to the product of masses. So here we have different conditions. First condition is what? The force between these two bodies is directly proportional to the product of masses. So suppose if one body mass M1, second body having mass M2, and this force is directly proportional to the product of masses. Fine. So here we have two quantities. One is left hand side, another is right hand side. So according to this directly proportional condition, if we increase the quantity, one side quantity, second side की quantity अपने आप ही क्या होगी बच्चे? Increase हो जाएगी. Fine. So if we increase the masses, force will increase. The gravitational force between these two bodies increases. So this is the simply meaning of directly proportional, सीधा proportion में. Fine. अच्छा, second thing is what? According to the Newton's that gravitational law, first condition is what? Directly proportional to the masses. ये तो बात clear हो गई. And second thing is what? Inversely proportional. So here is what? Not directly. Here term is what? Inversely proportional to the square of distance between them. तो सबसे पहले से देखो जरा. The distance between these two bodies are fine. So according to the Newton's law, क्या कह रहा है बच्चे? Inversely proportional to the square of distance between them. So inversely means बच्चे 1 upon relation. Inversely means 1 upon. So 1 upon में कौन बच्चे? Distance. 1 upon distance. R is the distance. And उस distance का क्या हो रखा है बच्चे? Square. So square of that distance. Fine. So inversely proportional means if one quantity increases, second quantity क्या होगी बच्चे? Decrease हो जाएगी. Suppose if we increase the value of R, it means the value of force is what? Decreases. So it means if we increase the separation distance, the force will decrease. If we decrease the separation distance, force will increase. I hope कि ये concept clear होएगा. So directly proportional means अगर मैं एक क्वांटिटी इंक्रीज करूंगा बच्चे, सो दूसरी क्वांटिटी भी इंक्रीज हो जाएगी. दिस इज द मीनिंग ऑफ डायरेक्टली प्रोपोर्शनल. एंड इनवर्सली प्रोपोर्शनल मींस बच्चे अगर मैंने एक क्वांटिटी इंक्रीज की है तो दूसरी क्वांटिटी क्या हो जाएगी? डिक्रीज हो जाएगी. सो दिस इज द मीनिंग ऑफ इनवर्सली प्रोपोर्शनल. सो डायरेक्टली प्रोपोर्शनल मतलब मास इंक्रीज करूंगा, फोर्स इंक्रीज हो जाएगा. इनवर्सली प्रोपोर्शनल मींस डिस्टेंस इंक्रीज करूंगा तो फोर्स क्या होएगा? डिक्रीज होएगा. जस्ट अपोजिट इन इनवर्सली प्रोपोर्शनल. फाइन. सो हियर वी हैव टू कंडीशंस, directly proportional and inversely proportional. So now combine these both equations. मैंने both equation को क्या कर देना है? Combine कर देना. So combining equation number 1 and 2. So what we have, मैंने combine किया इसको. So we have m1 m2 upon r square. Fine. So multiply m1 m2 with 1 upon r square. So कुछ ऐसा हो गया, that is m1 multiply by m2 1 upon r square. So it will become what? m1 m2 upon r square. Fine. So this side तो we have m1 m2 upon r square and we have directly proportional sign and we have force. So now we want कि ये proportional का sign हट जाए. So here we have proportional sign and we want कि ये proportional का sign हट के बच्चे मेरे पास क्या आ जाए? 1 equal to का sign आ जाए. Fine. So what we have to do? Suppose we have proportional sign एंड लेट्स टेक एन एग्जांपल, मैं एग्जांपल की उस पर समझाता हूं आपको. सपोज वी हैव टू नंबर, 5 is proportional to 10, or we can say that 10 is proportional to 5. I think in 7th 8th class you studied proportional, ratio and proportion पढ़ा होगा. Fine. So here 10 is proportional to 2. So it means कि जैसे ही मैंने यहाँ पे वैल्यू इधर इंक्रीज करी, सेम अमाउंट में इधर भी वैल्यू क्या हो गई होगी बच्चे, इंक्रीज हो गई होगी. सो ये 2 टाइम्स हो गया 4, सो 10 भी 2 टाइम्स हो गया 20. फाइन. सो इफ आई वांट कि ये 10 बच्चे इक्वल टू हो जाए 2 के, मैं क्या चाहता हूं बच्चे, आई वांट कि इस प्रोपोर्शनल साइन को रिमूव करके मैं कौन सा साइन लेके आऊं, इक्वल टू का लेके साइन लेके आऊं. सो मुझे क्या करना पड़ेगा, इस इक्वल टू के साइन के साथ एक कांस्टेंट के साथ मुझे इसके साथ क्या करना पड़ेगा, मल्टीप्लाई करना पड़ेगा. फाइन. और वो कांस्टेंट मेरे लिए आज क्या है, 5 है. इट मींस कि अगर मैंने प्रोपोर्शन का साइन बच्चे रिमूव करना है तो मुझे दो चीजें लेके आनी पड़ेंगी. वन इज इक्वल टू साइन एंड अदर इज वन कांस्टेंट. और यहाँ पे कांस्टेंट क्या है बच्चे, 5 एज अ कांस्टेंट है. सो नाउ हियर 10 और यहाँ पे 10. तो जैसे मैंने कांस्टेंट इंट्रोड्यूस किया बच्चे, दोनों क्वांटिटीज क्या हो गई, इक्वल हो गई. सो सेम हियर वी हैव वन साइड एज फोर्स और दूसरी साइड क्या है बच्चे, m1 m2 अपॉन r स्क्वायर. सो आई वांट कि ये दोनों क्वांटिटीज क्या हो जाए बच्चे, इक्वल हो जाए. तो मुझे इक्वल टू के साइन के साथ एक क्या लगाना पड़ेगा, वन कांस्टेंट, एंड दैट कांस्टेंट इज नोन एज यूनिवर्सल ग्रेविटेशनल कांस्टेंट. where this constant is what, universal gravitation. So universal gravitational constant. So I hope this formula is clear to you. So this is the final formula for gravitational force. Fine. So gravitational force formula is what, F is equals to G m1 m2 upon r square. So this is the final formula of gravitation. You know that the SI unit of force is Newton. Fine. And symbol is N. And now if we want to find out the unit of G. So question is, find out the SI unit of capital G. Fine. So बच्चे here this capital G is what, universal gravitational constant है ना. कंफ्यूज मत होना बच्चे, स्मॉल g क्या होता है, that is acceleration due to gravity. So here I am talking about this capital G and we want कि इस capital G का बच्चे मुझे SI unit find out होता है. So fine. So for SI unit at first so we have to write the relation that F is equals to G m1 m2 upon r square. Fine. So simple method is what, जिसकी SI यूनिट फाइंड आउट करनी है बच्चे उसको होल्ड करके रखना. फाइन. सो हियर वी वांट कि G की मुझे SI यूनिट फाइंड आउट करे, तो आई विल होल्ड G एंड रेस्ट ऑल द वैल्यूज को मैं क्या के लेके जाऊंगा बच्चे, दूसरी साइड लेके जाऊंगा. फाइन. सो इट मींस हियर आई एम होल्डिंग दिस G एंड रेस्ट ऑल द वैल्यूज विल गो आइदर साइड, है ना, दूसरी साइड चले जाएंगे, दैट इज m1 m2. फाइन. सो हियर आई हैव वैल्यू G एंड यू नो द SI यूनिट ऑफ फोर्स इज न्यूटन. फाइन. The SI unit of distance R is what, is the distance between these two bodies, and the SI unit of distance is meter. So Newton meter square upon m1 m2. You know SI unit of mass is kg. So kg multiplied by kg. Fine. So it will become what, Newton meter square per kilogram square, or we can say that Newton meter square per kg square. Fine. So this is the SI unit of capital G. And now here special note. So after this बच्चे one special note is there, and note is what, the value of universal gravitational constant G is, and the value of universal gravitational constant G is what, 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. So this is the value of universal gravitational constant. So if we want to solve a numerical and we want to put the value of capital G, we can simply remember this value, that is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. Okay students, now we have to discuss about the gravitational force effect on small object and on a big object. So one by one we can discuss about the cases. So first case is what, when we have a small object. Fine. So here we have object of mass 1 kg, both are of 1 kg. Fine. And in the second case, here we have object 1 is of mass 1 kg and second object is what, is earth. It means very big mass. So here I am comparing the gravitational force for small size object and for a big size object. ठीक है. So for reference I am taking mass object m1 बच्चे दोनों में common लिया है for a reference, and second mass में बच्चे क्या करा है हमने difference दिखाया. Here m2 is of 1 kg and in second case m2 is what mass of the earth which is 6 into 10 raised to power 24 kilogram, which is very large है ना. So we have to calculate the value of gravitational force in first case. F is equals to gm1 m2 upon r square, and you know the value of g, that is 6.67 into 10 raised to power minus 11, which is universal gravitational constant, and the value of g is what? Constant everywhere. Mass m1 is of 1 kg and mass m2 is of again 1 kg upon distance between these two objects is what? 1 meter, so 1 to the power 1 square. Fine. So here SI unit of force is what? Newton here. So when I calculated this whole values, and answer will come 6.67 into 10 raised to power minus 11 Newton. So here the value of force between these two objects of mass 1 kg is what? 6.67 into 10 raised to power minus 11. So power minus 11 is very small value. So अगर नहीं clear हुआ तो we can write this force as 0 ऐसे कुछ 0.0012345678 and 10 6 6 7. So this much Newton. It means 0.0000. It is a very small force है ना. So it means if we have a two small object and the value of gravitational force between these two objects, it tends to be negligible. ठीक है. So we can neglect the value of force. Suppose we have a two masses of mass. Suppose here we have a two pen. So इनके बीच में भी बच्चे gravitational force तो लग रही होगी. But the value of gravitational force, the amount of gravitational force, जो attraction है बच्चे, वो बहुत ज्यादा weak है. So that's why बच्चे हमें क्या नहीं होता बच्चे? Observe नहीं होता gravitational force between two small objects. Fine. But instead of small body, if I am having a large body, big body, अगर एक बहुत बड़ी body है और उसका mass भी क्या है? बहुत ज्यादा है. So gravitational force की value कितनी आएगी बच्चे? So gravitational force की value, suppose in the case of Earth, suppose one body having mass m1 का mass कितना है बच्चे? 1 kg है, and second body is Earth whose mass is 6 into 10 raised to power 24, and the distance between these two objects is what? Radius of the Earth, and radius of the Earth is what? 6.4 into 10 raised to power 3 kilometers, and our SI unit of distance is what? Meter. That's why मैंने इस किलो को बच्चे किस में चेंज कर लिया? 10 raised to power 3 में. So 10 raised to power 3 plus 10 raised to power 3 कितना हो गया? 10 raised to power 6. So here the value of small r, which is equals to the radius value 6.4 into 10 raised to power 6 meter. So now we know the formula. F is equals to g m1 m2 upon r square. Here m1 is mass of one object and m2 is the mass of Earth. So the value of g is 6.67 into 10 raised to power minus 11. Mass of first object is 1. Second object का mass which is 6 into 10 raised to power 24, and the distance between these two objects is what? Radius of the Earth from the center to the center of this body, and that distance is what? Radius of the Earth, which is equal to 6.4 into 10 raised to power 6. And बच्चे here is what? Here is square of distance. So here we have r value, and here is square of r. When we solve this whole value, and answer will become बच्चे 9.8 Newton. So this is what? This is acceptable value. This is very large value. It means if we have an object of 1 kg above the surface of the Earth, बच्चे, it will attract by the Earth with a force. If that object is of mass 1 kg, then that object exerts a force by the Earth, और वो force कितने का होगा बच्चे? 9.8 Newton का. So it means for heavier object बच्चे we can not neglect the gravitational force, but for lighter object बच्चे value of force is very small. That's why we are not observing that force in our practical life, है ना. But if we see the planets, the attraction between Earth and atmosphere or the solar system planets are what is rotating in an elliptical orbit. It is all attraction because of this gravitational force. Fine.